Okay, let's get going. Good afternoon, everybody. We've made it almost to the end of the conference, at least the talk sessions anyway. Well done. Only another 90 minutes of me to listen to. Then you'll be free to go. My name is Robert Smallshire. I'm the guy here on the left. My partner in crime is Austin Bingham, sitting in the second row here. And we have built up plenty of experience over certainly the last 5 years trying to implement DDD, or domain-driven design, in dynamic languages, and in particular in Python. Right? So dynamic language in this talk is kind of code for Python, right? But almost everything I talk about will transfer very easily into certainly any of the other object-oriented dynamic languages like Ruby or JavaScript, but also into fairly directly, but not so directly, into some of the functional dynamic languages like Clojure. Okay? So we work for a small consultancy based in Norway. We do consultancy mostly in Europe on these kinds of topics. So just before I dive into this, who here would say that they have some understanding of what DDD is, domain-driven design is, and how to apply it, or have experience of applying it? At least a few people in the room, I know, so I recognize them. Right? And who here counts themselves as a dynamic language person, someone who is familiar with or uses dynamic languages? Right? Now put your hands down if we take JavaScript out of the equation. Okay, a few people here. Which languages?
Both Python and Ruby.
Python and Ruby?
Python and Ruby.
Python and Ruby, okay. Okay, here. Right, okay. So I've become very interested in this topic because DDD is, well, at least 10 years old. Eric Evans, who's really the father or the godfather of domain-driven design, published what is popularly known as the Blue Book back in 2004. Of course, that's now 10 years ago. And this book has a kind of timeless quality to it. Almost everything in the book written in 2004 is still true today. There are a few omissions from the book, things that people have discovered are important in DDD, which aren't in the book, but I'll cover some of those things. And some of the architectural patterns have shifted over time as best practice, and our understanding of that has moved on. But it's a classic book, and it will still be in print 10 years from now, I'm sure. And also, many of these dynamic languages, Python, for example, Ruby, JavaScript now, have also been around for a long time, many of them over 10 years now. But what's fascinating to me is that there's been relatively little contact between these two worlds. Unusual to find any application of DDD in a dynamic language, so that's what I'm going to talk about today. I am going to talk about Python towards the end of the talk, but I don't want you to get the idea that we are Python zealots in any way. The both of us program in a wide variety of programming languages. I think we enjoy programming in most of them, most of the time. And you'll notice that not all of these languages are dynamic. Right? One of my favourite languages is F#, which is a very statically typed language. It's very effective language to work with. Some of these languages I choose not to use when I have the choice, like Perl, for example. You have to move on sometimes. So we're not language zealots, but we are language polyglots, if you like. We are capable of building solutions in all of these different technologies. And our general approach is to choose the right tools for the job. So I don't want you to get the idea that we are zealous about dynamic languages and think they are the only way to build systems. Clearly that's not true. So in terms of motivation for this talk, well, if you type domain-driven design in dynamic languages into Google, you'll get 3 hits. Right? You'll get 2 Stack Overflow questions, and you'll get a link to the talk you're sitting in right now. Right. That is basically it. There's a few more things I'll cover later. But this question has come up several times over the years. Why does domain-driven design seem only popular in static languages like C# and Java? And has anybody done any DDD in dynamic languages? Well, we'll answer both of those questions in the course of this talk. And after this talk, I should have to go Stack Overflow and answer the questions on that as well. So what's particularly fascinating to me is that domain-driven design is a set of techniques, and I will review what DDD is for people who aren't familiar with it. It's a set of techniques really for understanding and distilling a problem domain down into a software representation of that domain. Whereas on the other hand, languages like Python offer a way to engineer what I would call low-ceremony solutions. Okay? You can do quite a lot of stuff with relatively little Python code. There's not much ceremony. You're not going to spend large amounts of time coercing the type system and bending it to your will. You can mostly just get on with what you need to do, as those of you who work with dynamic languages will have discovered. So these two characteristics of these two techniques have the potential to be an interesting combination. So what we're going to do is look at how DDD and Python can be brought to bear as separate tools. One is a set of conceptual tools and patterns, and the other is a programming language, and bring both of those things to bear on any complex domain that you need to model. Okay, so this talk is in 3 sections. I'm going to start with a review of what DDD is. This is really aimed at people here who do not have experience of domain-driven design or have exposure to it, or would like a refresher on that. And this is where we talk about how DDD enables us to disentangle business from technology. Now I'm going to talk in a rather more philosophical section of the talk about what dynamic languages could do for DDD. What could be different about the way we apply DDD in dynamic languages compared to static languages? And are there any particular advantages to that? And then I'll round off with just some examples in code of applying very basic DDD patterns in Python. Okay? Python here is just, as I said, is a code word for whatever language that you care about. So, if you're going to do DDD, the first thing you need is some people who want to do DDD. Right? And this is very, very important. Those of you who are thinking of applying DDD in your organization, it is not going to work if you are the only person in your organization who A, knows what DDD is, and B, cares about applying it. Right? This is not something you can do on your own fruitfully, except on tiny projects where you don't need DDD. Right? So, the first part of any domain-driven design effort is to understand DDD and then educate all of the people you work with to also understand DDD. This is perhaps the most difficult part of adopting a practice like DDD, is arranging for the cultural shift it's going to need in your organization for people to begin looking at problems using this set of tools. Okay? And of course, there's much more to it than going out and buying 20 copies of Eric Evans' book. You need to get people to read it. This is a picture of a reading group at the company I used to work for, where we had a group every week, and we would read the book in our own time, and we'd meet for half an hour every week to review the chapter we just read, and discuss the ideas and how those ideas would apply to the situation we were working on. Very effective technique for raising the level of education about techniques in your organization. I recommend it. Well worth half an hour a week. But of course, it does require people to spend some time on their commute reading a big book. And look, they're all so happy. Because they're learning at work. Okay, so what is domain-driven design? Well, it's several things. It's a philosophy of bringing software closer to the problem domain. So rather than a technology-driven solution, where, so rather than say, oh, well, the first thing we're going to do, the first decision we're going to make on this project is that we're going to use Hibernate, right? And then we're going to go and understand what the actual problem is. Okay? And we're going to do that because we know about Python. Rather than that, we're going to learn about the problem first and defer some technological thinking, not just to a bit later, but defer some of those decisions potentially forever, insofar as we'll be able to change our minds about some of those decisions. So it's about involving domain experts. And everybody, all kinds of practices are about involving domain experts, but DDD has a very specific way of involving them. And it's a systematic approach to intertwining design and development. So there's some strategic design practices. I wouldn't necessarily call those software architecture, but they're strategic designs of the domain. There's some fundamental principles, which are almost always good to follow, and then there's a bunch of guidelines and rules which you need to apply with discretion. There's also a bunch of things that domain-driven design is not. It's not about specific technologies. There's barely any mention of specific technologies in areas of DevWeek. It puts technology in the back seat from a design point of view. Technology is important, but it's not the driver. And it's architecturally neutral, really. As there are various different software architectures that you can use to support a domain-driven design. Although obviously those different architectures have different qualities, which bring other things to your solution in terms of how your solution is going to behave and work. As you'll see, the notion of domain-driven design means that if you do it right, you can actually change your architecture to some extent around that. And it's not necessarily a heavyweight method. The heavyweight bit is learning about it. I'll try and deal with some of that this afternoon. But it is not a heavyweight method insofar as it does not require that you do all of your design at the beginning before you write any code. It's completely compatible with Agile. I told myself I wasn't going to use the Agile word in this talk, but I should do it. Agile, TDD, those other approaches. There's nothing to stop you using those approaches in order to implement a domain design. Completely compatible with that, and it can be used incrementally as the scope of the solution you need to implement grows. Now, this is one of the slides that doesn't project very well on here. This is Eric Evans' depiction of what domain-driven design is all about. And the details of this aren't so important right now. But what he has here is basically a bunch of bubbles here, each of which has a particular aspect of DDD in the bubble, and the connections between them showing how these things relate. So I know you can't read this, so I'll read some of the key ones to you. Basically, everything in this diagram flows out from this bubble here. And in this bubble it says ubiquitous language. And what this is saying is the first thing you need to do is establish a thing called the ubiquitous language, and I'll come back to that in a moment. That's really the first step. And then once you've established a language, or begun establishing a language, we can move on to design activities where we begin thinking about the kind of software things that you probably think about, like entities and values, and we all know what those are. But then, on top of entities and values, there's a whole collection of other patterns and constructs which are used to organize those entities and values in useful ways. Things like aggregates, bounded contexts, for example. I'll come on to what those things are. The key point of this diagram is that everything here flows from this ubiquitous language. The third thing that DDD is a community. It's a community of people out there who advance the cause of DDD because they found it's a very effective way to solve problems. And so there's at least one DDD focused conference here in London every year, DDD Exchange, and the kind of people who present at that conference are also the kind of people who continue writing books about DDD. Eric's book is quite dense. It's pretty hard to get through, I'll be honest with you. A much more accessible book, which is much more recent, is Implementing Domain-Driven Design. This book by Vaughan Vernon, this book has a lot more code in it. So So it's much easier to understand the implications of DDD than how you might put it into practice at a code level. And this is very much a book that I would say, you work through from front to back and get a progressive understanding of it. Whereas this is a book you need to read, and then several years later it will make sense to you. So when you've tried to apply it and found that you didn't quite understand the book. So I think both of these are good reads. There's also a much lighter weight version called Domain-Driven Design Quickly, which is a condensed version of the blue book. That's a free ebook. You can download a PDF if you just Google for it. Also a good starting point. Okay, so let's move on and look at the specifics of DDD tools and techniques. Now, many people, and I've been guilty of this as well, when you go into modeling a domain, you think, I know, I'll model the entities and I'll model the values, and we're done. And of course, there's so much more to it than that, because they are only two tools. So let's look at what the other tools are. Well, the first tool, as I mentioned, is the ubiquitous language. And of course, DDD itself has a language, which I've depicted here. And you'll see that the word language is very important within the world of DDD. Everything resolves around establishing a language. And the point about a ubiquitous language is that it's a glossary, if you like, of terms which you arrive at through, in my experience, through a process of negotiation with domain experts. Domain experts tend to be quite vague a lot of the time, don't they? Whereas we require precision and unambiguous terms. Yeah? So negotiating with the domain experts about what the words mean, capturing their understanding, but ultimately trying to use their words for things and not our words for things is really the goal of ubiquitous language. And it's not just words for entities and values, it's words for events that are happening in the system and any significant changes that are going on in there, any significant behaviors of the system. So this is a really key part of the DDD process, and I will not lie to you, it is a very difficult thing to do. If you manage to do it well, it has enormous value. Enormous value. Because then you end up with a software system which everybody can get behind and get around and understand. So, in the Python context, a lot of dynamic language programs, in Python for example, if I drew an object graph of how they're working inside, they look like this. There's just a bunch of objects connected to each other with references. Just plain old Python objects, regular references between them, and some object graph that represents whatever domain that we're interested in. And there aren't many tools that play here. Just objects of various shapes. And as I said, the first step, once you have ubiquitous language, is obviously to try and identify entities and values. And this is something I'm sure most people here are familiar with, the concepts. Entities are things which are identifiable, they have a unique identity in the domain, whereas values are things which measure or describe quantities in the domain. Right? So, I am Robert Smallshire, and I will always be Robert Smallshire. Right? Various characteristics of me will change over time. I'm not the same person I was in a value sense as I was 10 years ago. Lots of things have changed about me over the last decade, but I'm still the same guy. Right? So I'm an entity. Whereas the 5 krona coins in my pocket are interchangeable. If I give you a 5 krona coin or a £1 coin, it doesn't matter which one I'm giving you. They're completely interchangeable values. And they're comparable in interesting ways. And so and these are rules of thumb, is the entities in the system are generally mutable in some sense. An identity, the characteristics of that thing will change over time. Whereas preferably the values in a system, you should make them immutable. And you need to do a little bit of work in dynamic languages to make that happen. Most dynamic languages, it's extremely easy to mutate everything. Okay, so you might want to put a bit of extra work into your value types over and above what you would normally do to prevent them or essentially to make them immutable, or to make them as immutable as you can. Okay? So far so good? It's really warm in here, and it's Thursday afternoon. Okay, the next tool, which is a DDD, a really core idea of DDD, is the notion of an aggregate. This is shown here in the kind of yellowy-orange colour. And it's easy to be misled into thinking that aggregates are just object clusters. They're just collections of related objects that are tightly clustered in the object graph or in the model, and that is an aggregate. That is not necessarily true. In fact, I would go so far to say it is not true. That is not what aggregates are about. Aggregates are about establishing boundaries around parts of the system where consistency of the objects and relationships and the values within that boundary is particularly important. So they're consistency boundaries, not necessarily clusters. To the extent that some aggregates may have only one entity and a few values in them. In fact, some research I was reading said that in fact most aggregates contain only one entity. Okay. So if I say something is an aggregate, that's saying something about a boundary within which I want to keep things consistent, within the scope of a unit of work or a transaction. So a rule of thumb here is that a transaction or unit of work should modify only one aggregate at a time. So you can turn that around and use that rule to help you find the aggregates in your system. So you notice that each of these aggregates has one entity that's special. I've drawn it just poking out the side here. And each aggregate has exactly one special entity. That's called the root entity, the aggregate root. And the aggregate root is the object that is responsible for maintaining consistency of all the other objects that live inside the aggregate boundary. Okay? So the aggregate root objects tend to have generally just more code in them because they are responsible for adjusting or maintaining the consistency of the other objects within the aggregate. What's also really important is that you'll notice all the inter-aggregate references, the inbound references to every aggregate are to the root. Okay, we have no inbound references to an entity or a value within, embedded deep within an aggregate. We always refer to the aggregate root. And then if we need to find another entity within the aggregate, it's up to us to navigate then from the root to that object. Okay, so these are rules which help us manage the complexity of how the model is organized. Another important thing is that all aggregate or all inter-aggregate references are not just regular references that you have in all languages. They are specifically done by ID. So as I said, all entities have a notion of identity, and all inter-aggregate references are done by referring to that identity rather than to the object directly. Okay, and that's important because it means that we don't necessarily have to have the entire model instantiated in memory at any one time. Right? We can pull parts of it in, we can push parts of it out, we'll talk about how we do that later. So that's another important characteristic of aggregates, is that they allow us to break up the model into parts that we can have live in the computer. Now, if you go to the Blue Book, Eric Evans' book, and you look in the index for the word event, you'll find it's not there at all. There's no mention of events in the Blue Book. And this is one of the really important things that has been recognized since the book was written, that events, or specifically domain events, within the domain are very, very important things for lots of reasons. And so this is one of the things you really need to be aware of if you go and work through the Blue Book, is that there's a whole chapter missing, right? And if you look in some of the later books, you will find that there are whole significant chunks of the book are about handling events in the system. So what is a domain event? Well, it's anything that happens in the domain that domain experts care about. And when you think about that a little bit, that translates into anything that happens in the domain. So basically any state change in here is interesting to somebody who cares about the domain model. Otherwise, you wouldn't be changing the state. If it's not interesting to somebody who cares about the domain model, why are you changing the state? You shouldn't be, right? So, essentially, domain events are anything that changes. And again, a rule of thumb here is to use, again, I'm not going to mention any specific technologies here, but use a very lightweight publish-subscribe pattern rather than a subject-observer pattern for your domain events. The reason for that is it means that you can subscribe to events from objects which do not yet exist, right? Whereas if you're using a subject-observer pattern, you can only subscribe to objects which are already there to subscribe to. Choose your patterns carefully, your event patterns carefully. Next important aspect of DDD is factories. Now, I'm sure you all know what a factory is. It's a function, effectively, which creates objects, right? But that's just like constructors. Constructors can create objects as well. The factories are very important in DDD, and it's important that we always construct objects through factories, not just for technical reasons, but because it gives us an opportunity to use or employ the ubiquitous language in the code, right? As an example, if I want a glass of water, right, from somebody else, I don't just go up to them and say, glass of water, right? Because that's what the constructor of this thing is called. It's glass of water. That's quite rude, isn't it? I would go up to them and say, can I please have a glass of water? They would give me a glass of water. Right? And that's part of the language of the domain. Right? And having a factory function enables you to use that language in your software. Right? So rather than just calling the user constructor, you might have a function called register user. Right? You tend not to have your if you're using a ubiquitous language, you tend not to have factories which are called things like create user, because that's just synonymous with a constructor, really. Trying to use the actual language that the domain experts would use. So factories facilitate entity and thereby aggregate construction. They allow us to express the ubiquitous language. We can use verbs then instead of nouns for creating objects, very important. And they hide the construction details, like where the IDs come from. That's an important thing. The next aspect of DDD is repositories. Red things I've drawn here, which kind of sit outside the aggregates. And repositories are a mechanism for giving you somewhere to put aggregates, so they can go and live in some persistent storage somewhere, and to retrieve aggregates from persistent storage later. Okay? And again, a rule of thumb is that you would normally have one repository per aggregate type, as I've drawn here. So a repository is where you go when you want an existing aggregate, whether it was made 30 seconds ago or 10 years ago. That's where you go. And these are, I would say the repositories are architecturally significant. I made a bold claim earlier that DDD is architecturally neutral, but repositories are the one thing in a domain model that really ends up being abstract, and you don't commit to the details of how that thing works, because that is technology specific ultimately. At some point, your aggregate has to end up in an actual database, right? Rather than just some abstract notion of a repository. So at some point, you have to commit to the technology. We do that outside the domain model, but the repositories tend to be abstract. Whereas everything else I've shown so far can be a concrete thing that you can actually instantiate. And then a very important concept in DDD is this notion of a bounded context, which I hope you can see in grey here. There's 3 bounded contexts here. And a bounded context is the scope of a ubiquitous language. So So in any large enterprise, with multiple departments, people dealing with different aspects of the same thing, each of those departments will have their own language, their own ubiquitous language. And if you're going to one department and trying to establish what their ubiquitous language is, and you're going to the department next door down the corridor and talk to them, they may well have a completely different ubiquitous language. There might be some overlap. They might use different words for the same thing. Okay? And those boundary contexts are a boundary, or a scope, if you like, within which a ubiquitous language, or a particular ubiquitous language, applies. It's very important to identify those. Of course, this doesn't occur in small domains. Okay? But when you're dealing with larger systems, you inevitably run into this. And actually, a failure to deal with this properly and identify it fairly early on actually can lead to some quite serious problems. And then you end up with exactly the same problems that every other software project on the planet has with inadequate domain models. So the point of bounded context is they prevent you or strongly discourage you from trying to model the whole damn enterprise in one model. That is not going to work. It's about more focused models, which are simpler because they're smaller. That means they're easier to build. It means you're more likely to finish building them, and it means they're more likely to work when you do build them. Okay. So it's about reducing scope. And then when you've implemented your bounded context, they should talk to each other in a fairly loosely way. These tend to align with technical components in the system. And there are lots of different types of bounded contexts, ones which are imposed by technological constraints or ones which Will this make sense? Will fit together? Okay. And then, of course, when you have identified bounded context and these things need to talk to each other, you need some way of them talking to each other and some way of translating between the different contexts. And you end up with this notion of context map, which is two things. It's both a conceptual thing. It could be a document saying, well, this word in this ubiquitous language means the same thing as this word in this ubiquitous language. So that enables us to have conversations with both of these sets of people and figure out what they're talking about. It's also a physical thing. The context map is very likely to end up as an actual piece of software at some point. And there are lots of different ways of implementing context maps depending on the situation that you're dealing with them. They may just end up being an API where the stuff in here can call an API on here, which translates stuff behind the scenes to talk to this. Right? There's a pattern called the anti-corruption layer, which you can use. That's a type of context map, where you have a piece of software which is responsible for preventing incoming data corrupting the content of the model. These are the little boxes on this diagram of the projects I've worked on, where we have a shiny new domain model and a horrible legacy system down here, which was not derived by DDD. This is about 15% of the effort, and this is the other 85% of the effort. It just goes into anti-corruption layer. Okay. This diagram is not to scale in terms of effort. Okay, so back to Eric's diagram. I've coloured in some of the bubbles now. And you'll see that we've actually covered a pretty significant number of the bubbles on here. There's only a few we haven't covered. I haven't covered domain services. I'm not going to talk about those today. And in fact, many of the other bubbles here around here are just specific types of context maps, the thing that I was just talking about. So we don't need to go into the details of that. So I've given you, I think, a fairly comprehensive overview of some of the key patterns and elements of domain-driven design. Right? Okay. I did say DDD was kind of architecturally neutral, but I do want to talk about an aspect of software architecture which I think is crucial to building good, valuable, long-lasting domain models. Now, nothing I've talked about so far requires complicated frameworks, proprietary infrastructure, fancy architectures, enterprise anything, right? You can sit down with your editor and you can make a domain model in in just code, right? You can just sit down and you can do it in any language you like, just using plain old objects. You don't need any technology, right? And actually, I would advocate that that is what you should do. Your domain model should have no technological dependencies on anything, right? Technologies come and go like the weather, right? Especially if you're using something like JavaScript. I mean, you know, oh, it's Wednesday. What's today's JavaScript framework? So, and the point about domain models, and if you're investing in building domain models, is they're probably going to be valuable over the long term. Data tends to outlive applications, and applications tend to outlive specific technologies. Right? So don't tie your data to a specific technology. That's an incredibly dumb thing to do, actually, if your data is going to be valuable over the long term. However, if you go to the blue book, you'll see this diagram. This one here, which is a 4-layer architecture where we have UI, it's an application layer, a domain layer, and an infrastructure layer. So infrastructure means databases, object relational mappers and stuff, right? All that stuff that we all enjoy using so much. And you'll notice that the domain model is implemented in terms of the infrastructure. Okay? Now, when you read this in the book, perhaps you should take this as a warning in the book. It's not written like that, but it should have a notice on it now that says don't really do this unless you have to. This was a sensible thing to do in 2004, but we've evolved much better ways of building systems since then. You should be wary about following all the advice from 2004 without finding which parts of that advice has gone stale since. And I think this is one of the pieces of advice in the book that has gone stale. I've made the mistake, actually, myself, of when I first went into DDD, of seeing this diagram, thinking, okay, and implementing it. And that's a big mistake. It turned into a big mistake. I didn't realize at the time. So, use these things with care. I was at the DDD Exchange conference here in London last year. Eric Evans himself was speaking there, and he came up with this wonderful quote in one of his talks, which is fantastic. Object relational mapper takes two brilliant ideas, the object model and the relational model, and incapacitates them both. And I think anybody who spent any quality time with an ORM probably feels like that about it, sooner rather than later. It's all very well when things are simple at the beginning, but as soon as you want to do something slightly out of the ordinary that the framework doesn't really want you to do, things can get very awkward very quickly. So what's the alternative? Well, there's a whole bunch of alternatives, some of which have been around for a very long time, but I think it's taken a while for the industry to take this on board. Uncle Bob Martin, advocates a thing called the clean architecture. It's easy to find a video of Uncle Bob talking about this. It's usually worth watching. What's interesting about this architecture is it is layered, concentric layers, it's still layered, but the entities, which is Uncle Bob's code word for domain model, are in the middle. Right? Around that we have use cases and then controllers and presenters, and then on the outside we have devices and databases. UI. Right? So the database is on the outside of this architecture, not buried right in the middle of it. Okay? Alistair Cockburn advocated a long time ago now a thing called the hexagonal architecture. His code word for domain model is application. Right? He means domain model really when you go and read about this stuff. But the key point about this diagram is, well, where's the database? It's not right in the middle, it's out here, it's on the outside. It says database access service. The database is on the outside of the system, not buried in the middle of it. There's a thing called the onion architecture by Jeffrey Palermo. This is perhaps closest to what I think we should shoot for, just because the words match what we're talking about here. He's using the same language we are. He has the domain model in the middle, and domain service layer around that, and application services, and then UI and infrastructure around the outside. Again, the database is on the outside, not in the center. Now, in my view, all of these architectures, when you read about them, they all have different names, and they're all basically the same thing. Right? They're essentially isomorphic to each other. You can just change the labels on the diagrams and they are the same thing. They have different ubiquitous languages actually in different contexts, but they're basically the same thing. Right? And the key thing they have in common is that they place the model at the center, because that is the most valuable thing you are building. It's the thing that's going to last a long time, and they externalize the infrastructure, the particular database technology you're using, or whatever else. That stuff comes and goes. Don't make yourself dependent on it. Stick it on the outside. Does that make sense? Yeah? Anybody doing that? People working in systems that are built this way? A couple of people, right? Is anyone else going to go back and do this now in the next project? Have I changed any minds? You are. You are. I am. Right? Some of us have learned the hard way that this is the right thing to do.
It's not easy.
Well, it's not easy, right? But it doesn't have to be that hard either. I think it depends on other factors, like what technologies you are forced to use and legacy things. Okay. The next part of the talk is perhaps more speculative, right? Maybe even fun. And hopefully it'll make you think, a bit philosophical, about the nature of software systems and how they model the world. But I asked myself a question, well, this is okay. I convinced myself we can do DDD in dynamic languages because all we need is to be able to write classes, create objects. Of course we can do DDD. Nothing I've shown you so far needs anything other than the ability to create objects. But what can dynamic languages do for DDD? Is there anything different that we do for DDD? Well, what can go wrong in software systems? Hardware problem, right? You can have some programming error. You can get cosmic rays, earthquakes, right? Joe Armstrong, guy behind Erlang, says there is no such thing as pure functions because of cosmic rays. But what we all fear when we're working in dynamic languages is this. We fear the type error, right? This is what we're scared about. This is why people do static, or a lot of people do static typing, and worry about type errors. Now, there is some research, and I've done some further research, that actually type errors in actual dynamic language systems are actually pretty rare. They're about 2% of all the errors that exist in a system. So they're not a significant fraction of the errors that we put into systems anyway. So I tend not to get too worried about this. But we do get the sense sometimes that we're trying to build these fabulous temples on top of some teetering infrastructure, some dodgy language that we should never be using anyway. And philosophically, what is a dynamic language? What's a dynamic language? You don't know either. There's a good argument to be had that dynamic languages don't even exist. Right? Let's have a look at that argument. There are lots of different ways of characterizing type systems, right? This is going to be a bit heavy for this time of day. There you go. We have weak versus strong. JavaScript and Perl over here. The system will do type coercions for you when you're least expecting it. Right? Whereas strong over here, where the system won't coerce types for you. We have untyped languages like assembly. If you have a value in register number 2, right? What is the type of that value? You don't know, right? It could be an int, it could be a float, it could be half of a Unicode code point. You don't know, right? It could be anything. So there aren't such things as untyped languages. We have inferred languages. Obviously, C# is quite good at this now. F# is very good at it. Does Java have inference yet? At all? No. And then we have manifest typing, where you have to spell everything out very laboriously every time. compiler's not smart enough to infer even the most basic things. There's structural typing in languages like Python, nominal typing in languages like Java. Structural typing is about the shape of objects rather than the name of objects. And we have static and dynamic typing. If I do A equals 5 in Python or JavaScript or Perl, what is the type of A? Because on the next line, I can do A equals Robert as a string. Now what is the type of A? Right? In fact, A doesn't have a type at all. A is untyped and points to a thing that has a type tag, essentially. So there's a good argument to be had that the dynamic languages don't actually exist. They are just untyped languages. And this is what the type theorists will have you believe, is that there are no dynamic languages. There are only untyped languages where every object has a tag on it saying what type it is, which is interesting. My experience of working in a variety of different languages is that you have very expressive, sophisticated type systems in Haskell over here, right, which can be a joy to work with. Right? But they can also be a lot of work to explain to the type system what you mean. Right? I don't think anyone's going to claim just yet that programming in Haskell or learning to program well in Haskell is necessarily a very easy thing to do. Right? And then on the other side we have JavaScript and Clojure, and Python, and these languages. And then in the middle we have these weakly expressive type systems, which are just a disaster. Right? Because you spend, like Java generics, actually, you can put an enormous amount of effort into satisfying the type system in Java for almost no benefit whatsoever, because it will delete all your types anyway before it leaves the compiler. So this is really the wrong place to be in terms of using a type system. You're just better off not having it, because at least you don't have to do the work to satisfy the thing. What's really interesting, I think, is this middle ground here. Languages like Dart coming now, typed Clojure coming now. What's the Microsoft one? TypeScript, with optional typing or gradual typing. This allows you to ignore typing unless it's cheap to do and useful.
I think TypeScript came out officially yesterday.
Did it? Okay.
On the Build conference.
Right. Excellent. So I need to spend some time with TypeScript, because I think this middle ground is actually a very exciting space at the moment. Very exciting. Now talk about some of the research that's been done, and there's a wonderful paper which you should read by a guy called Stefan Hallenberg, called, I'll read the title to you, An Experiment About Static and Dynamic Type Systems, Doubts About the Positive Impact of Static Type Systems on Development Time. Right? And this is a really fascinating experiment. What Hallenberg did is he actually invented a new language, a programming language, and he made two variants of it. One that was statically typed and one that was dynamically typed or untyped. And he had a bunch of people solve the same problem in both variants of the language. And of course, in the dynamically typed language, there were type errors, a few type errors. 2% of the errors were type errors when you ran the program. Right? So then you have to go in and fix the type errors. And it turns out that doing that took less time and less effort than satisfying the type system in the dynamically type version, in the statically type version. So it actually takes less effort to write a dynamically typed program and then fix it, because you're going to test it anyway, right? Than the time required to handle the type check in the first place. So it's a really interesting result, which is a few years old. And then of course people will tell you that, well, you can't possibly write reliable systems in dynamic languages. Well, actually you can. The most reliable systems on the planet are built in dynamic languages, like Erlang. Types have almost nothing to do with reliability. But I think what's really interesting about the dynamic languages, and I'm going to exclude JavaScript from this part of the discussion. None of what I'm going to say applies to JavaScript. But an argument has been made, which I think is quite a good one, that types are anti-modular. Right? That sounds like quite a controversial statement. But then if you look at how all of our systems talk to each other on a larger scale, what do we do when you want one system to talk to another system? First thing you do is you turn all your data into JSON, right, which throws away nearly all the type information. Right? Then you turn it into text, right? And then you stick it in an HTTP message and send it over the wire. Right? There's almost no type information is transferred between systems. Why is that? It's because types are anti-modular. Because the cost of sharing the types between those systems is very high because it causes those systems to be coupled. Right? So a lot of what we do is not actually strongly typed programming, it's stringly typed programming. Who's ever stored any interesting data in a string that really shouldn't have been in a string? Come on, everybody's hand should be up. When did you last do it? I bet you've all done it this week, haven't you? Right? Happens all the time. And the reason we do this is because it's very convenient. It actually works a lot of the time, and it prevents us having to share types between systems. Or we do it because we're really lazy. That's the wrong reason. Now I'm not going to read all this wall of text out to you, but a really interesting discussion, I forgot to put the URL on here, but a really interesting discussion to have that has been had is between this guy Breakout, I don't know how to pronounce his name. He's on the Dart team at Google, and Phil Wadler. Has anyone seen Phil Wadler speak? He always bursts out into his Lambda Man costume at the end of the talk. It's worth seeing him speak just for that. It's very, all of his talks are extremely dense computing science, right? But even if you have to sit through 90 minutes of logic, right, it's worth being there at the end. So I recommend here he is in his Lambda Man outfit and just burst out at the end of the talk. But what's interesting here is that the Dart guy is saying that types are inherently non-local. They describe data that flows across module boundaries. And the absence of types won't buy you modularity on its own, far from it. But types and type checking act as an inhibitor to modularity. Right? And Wadler comes back in this argument and says, well, actually, there are really two types of modularity. There's S modular, you can tell you're a computer scientist, like a real one. So there's S modular, which is separate compilation, or a system supporting separate compilation, and I modular supporting independent compilation. Basically saying, well, yes, types are anti-I modular. Right? If you have type coupling between systems, and I change the type in one system, you have to recompile your system. I have to give you that type information somehow, and you have to recompile your system. You know, we're getting into a world now where everything is connected to everything else. So cascading changes going through systems caused by type changes is not acceptable, which is why we stick everything into strings and send them over the wire that way. So that's a problem. Rich Hickey, inventor of closure, I'm going to quote him because he's much smarter than I am, has a very similar argument. Not about modularity, but about, this is a really central point to DDD, about how programs model the world and represent the world. Right? His argument is that type systems only check that your program is internally consistent with itself. Right? I can make a very well-typed program that has a completely inaccurate model of reality. Right? Whereas DDD is very much about building programs which accurately model reality. You don't need a type system to do that. Hickey would argue that, in fact, not only the type systems get in the way, but there is just no connection between those two things. The connection between the outside world and the premises of your type system will always be outside the scope of any type system. So types are about making programs which are internally consistent. DDD is about making programs which are right about the world. Okay? And if you look at many strongly typed programs, the types in them just aren't very interesting. Look at that in a moment. Finally, I'm sure you all know your solid principles. I'm not going to put anybody on the spot by telling you what they all stand for. It's a bit late in the day for that. But one of them in particular, the interface segregation principle. Uncle Bob again, says that no client should be forced to depend on methods it does not use. Right, so when we apply this in Java, what does that mean? It means we take our class with lots of methods and extract lots of very narrow interfaces from that, and we refer to those interfaces when we pass objects around. And a good interface is one that has one or two or maybe three methods, not 50. Follow this advice, you tend to have classes which implement lots of different interfaces. This sounds to me just like duck typing. Right? In Python, nobody depends on anything they don't use. If you stop using a method, fine, you no longer depend on it. If you start using a method, fine, you depend on it. So it seems to me that duck typing and late binding in the small talk sense is really the logical, very late binding, is really the logical conclusion of applying interface segregation principle to programming. I'm not sure whether Uncle Bob would agree with me. That's it. Anybody think the world is statically type checked? Do we live in a statically type checked universe? What's the type of a medical record? Other than just saying medical record. That's the easy answer, isn't it? Right? If you could come up with a type for a medical record, could you usefully check it? Would it be robust against the kind of things people are likely to stick in medical records in the future? My brother swallowed a piece of Lego when he was about 5 years old. And when he was about 30, this piece of Lego, which was extracted from his stomach, turned up in his medical record, taped to the page. I'm not sure how you digitize them. But it just shows that you can't necessarily predict what kind of information is going to end up in these things. And so in dynamic languages, saying this is a medical record is just metadata in the object. We have an object, and it just has a label on it saying medical record. It's just a label. And of course, this is why we're moving much more toward now towards systems which work with document storage and passing documents through systems where not all parts of the system need to be able to understand all parts of the document, but they can maintain the document and pass it down the line to other systems. So all this document storage stuff is very, very dynamically typed. You do it because it's useful, because that's how the world works. The world is full of documents. I said I loved F#, and I do love F#, but I'm going to have a little bit of a go at F# now. Right. This is a geezer. In fact, it's the geezer in Iceland, at the place called Geezer. And there's some data that was kicking around in some F# discussion about geezers. There's 2 columns of data here. So this is a domain, right? This is the domain of geezers, right? It's probably a more interesting domain than some of the domains you work in. And this domain has basically 2 interesting values in it, right? It has the duration between eruptions of the geyser, and it has, the duration of the eruption and the amount of waiting time between eruptions, right? In 2 columns of data. And F# has this really neat feature actually called type providers, where it will actually cook up a type for you that represents some data that you give it by example. So you give it some example data, and F# says, oh, I know what type this is. I can do this statically, in fact, based upon this example and come up with a type. And what F# says is, well, it says, well, the first number is a float, and the second number is an int. Fair enough. Do you think float and int are interesting types in the domain of geyser studies? If you went to a geologist, right, and said, well, I think this is a float and an int, do you think that would mean anything in their domain, in their ubiquitous language? Of course not. right? The fact that they're floating integers is not quite irrelevant, but it's really, really not an interesting characteristic of this data, right? And the fact that we can statically type check it, so what? It gets worse than this because, well, they're not interesting types in the domain. And what if some, the next observation is this. Now the waiting time between eruptions is 53.5 seconds. Is it reasonable for a geyser to erupt every 53.5 seconds? That's okay, isn't it? Geysers aren't allowed to do this, right? The universe works this way. Right? It's fine. But what happens now? I have to recompile my F# program, right? Because someone has come up with a new, completely valid observation. It's nonsense. So I've actually very tightly bound my software to some completely irrelevant quantities in this domain. Right? I got quite annoyed with this class because they thought this was wonderful, and I just think it's stupid. Right? It's just technological masturbation, really. It's just incredibly good fun from a type theoretic point of view, but ultimately very unproductive. Right? Whereas in a dynamic language, what would happen? You'd read in these things, and you'd say, well, this is a float, this is an int, this is a float, this is an int, this is a float, this is an int. And you get to this line, you say, oh, this is a float, this is a float. Fine. And I end up with a list where all of these elements are integers, and that one was a float. Is this a problem? Of course not. What am I going to do with these numbers? I'm going to add them together, I'm going to subtract them. I can do those things that ints and floats. Right? No problem. So just tag the values, rather than worrying about the types of the thing. This seems silly, but this is a real domain with real data. Okay. TDD in practice. Well, can it be done? Yeah.
Just got one question about the readability of code.
Yeah.
Like if you have a statically typed language, sometimes at least I feel it's easier to understand, okay, that's what it's neat, or that's what I get. So in a dynamic language, I have no clue what I get.
Maybe if you work in Java where the types are written down all over the place, but if you work in F#, you can read the code and there's almost no types in it written out. Right? I mean, okay, your tools can help you infer types, and Visual Studio will give you some of that information. But to be honest, I think if you're using a ubiquitous language in your code, right, and you have method names and class names and things which come from the ubiquitous language that you understand, that is much less of an issue than you might imagine. Maybe it takes practice, right? I've been doing dynamic languages and static languages for years, and I'm pretty comfortable in both of them. And also, a lot of the dynamic language tools are much better now at figuring those things out for you. Well, can it be done? It's an important question. Well, yes, it can, because we've done it. And not on a trivial domain either. So, until about a year ago, we worked for 5 years in the oil and gas sector in Norway, where we're based, building domain models using domain-driven design in a very complex domain. Now, I'm not going to go into great depth about this domain, but I'll just quickly explain what the domain is about. It's going to be a DVD talk. Basically, to find oil and gas, you have to build some models of what is inside the Earth, and you can make some predictions about where to go and drill holes, right? Get the oil and gas out. And so we go out and do these seismic surveys on boats, usually. This is like doing, the ultrasound scans you have when you're pregnant? It's like that on the whole Earth, or a large part of the Earth. That produces vast amounts of data. We drill holes in the Earth, wells, and we send very expensive instrumentation packages down those holes to measure the properties of the rock and the oil and stuff down the holes. We then use that data to build models in the computer. So this is all geometry. We then give those models to statisticians who fill them up with predictions of what type of rocks are there. And then we give those statistical models to physicists who do physics and predict where the oil and gas is going to be. Right? This is really interesting for several reasons. One, because it's a huge, very complicated domain. This is not a process that is done by like 5 people, right? This is a process that is done by thousands of people in very large corporations, some of the largest companies on the planet. And running through this process takes at least 2 years, right? And these people are geophysicists, these people are drilling engineers, these people are geologists, these people are geostatisticians, and these people are physicists. Do they all speak the same language? No, not at all, right? And it's a huge problem actually in these corporations. And so the first thing you need to do in a really complex domain like this is say, well actually, these people have completely different lingo, different languages for the same thing. Therefore, these must be bounded contexts in the system, right? And then we can start thinking about how to model within each bounded context, rather than trying to make some incredible domain model which covers this huge complex domain, which people have tried and largely failed to do. We can go in and make more targeted, focused domain models, which we're going to build because they're smaller, right? We can make different technology choices to each one because they're independent. Right tools for the job. You're not going to have a 1 terabyte entity, and I'm not joking, this is one entity that is 1 terabyte, right? So it's just a very large 3D array, right? Very, very large amount of data. So that's a terabyte entity. You don't do that in Python, right? You do that on your graphics card with lots of C++ and OpenGL shaders, right? That's really the only way to handle that amount of data with the performance constraints you need. Yeah. So these are very much bounded, nice examples of bounded contexts, and I've drawn 5 here. If we do this for real, there's like 30 different bounded contexts with different languages in use, and they all relate to each other in interesting ways. Now, okay, I said this is OpenGL shading programs and C++, and that's true, but we completely implemented this domain model in Python. Right? And there's still a significant amount of data kicking around. In fact, really large amounts of data kicking around. But we completely built this in Python and had it talk to the other domains which were written in C++. Right? So it is possible to do these things. And much, much easier to do in Python than it was in C++ in this case. So, just to talk about domain-driven design, so we need a domain to look at. So just an example, so you can get an idea of some of the stuff we're working on. So this is the seismic survey context, if you like. It contains these large 3D arrays. You can probably see why you can't do this stuff in Python. Moving these amounts of data around. And then we have a different context here. So we're going to superimpose data from different contexts into the same physical space, because all of these things represent stuff in the same parts of the planet, right? So then a geologist has come in and interpreted this data to make a model of some layers of rock and some faults through that rock. And then the statisticians come in and stick some properties in here about how they think things might be. And then we have the physics people coming in trying to simulate flow of fluids through these rocks. Right? And in a minute you'll see some oil wells come in. They're not very exciting when they do come in. Now, these lines here, which actually have enormous amounts of data attached to them, are entirely modeled in Python in the system. And the entire domain model behind the oil well and the drilling information that's attached to that, all the sensor data that's collected from those wells is in a self-contained Python domain model. Other people have made some progress, not in Python, which is one of my weapons of choice, but in Ruby. There's a guy called Paul Rayner. I'll make these slides available afterwards if people want the URLs. But a guy called Paul Rayner re-implemented the classic DDD example, which is about shipping containers in Ruby on Rails. And what's really fascinating about what he did is he actually managed to implement the onion or hexagonal architecture and turn everything inside out, and still use Rails to do that, which I thought was very interesting. So that's worth a look. And this guy, Victor Safkin, as well, has also published some stuff on using DDD in a Ruby context. We have our own example. Is anybody here coming to our workshop tomorrow? Okay, nobody. Hopefully someone's coming to our workshop tomorrow, otherwise I can change my flight. So we have an example, which is one we'll be working through tomorrow, which is entirely written in Python with a onion architecture for a domain of project management. Okay, so anyone who does come to the workshop tomorrow will be building this domain model from scratch. We're going to start with no code, and at the end of the day, we're going to have a hexagonal architecture with a self-contained domain model in the middle, and an event store, which we're going to write as well from scratch. Should you do DDD in dynamic languages? If your domain is complex enough and valuable enough, if you're going to make an application that has a lifetime of 6 months, it's probably not worth it. Right? If you're going to make an application where the data and the domain has a lifetime of years or decades or centuries or whatever it's going to be, right, then it is worth making the investment, as long as you don't couple your domain model to particular technology. And unfortunately, this is what is happening in the dynamic language world. I've just put up a couple of Python web frameworks here. Django, is anyone using Django here? Or Pyramid, another web framework in Python. You'll see they all have this 2004 architecture. Right? You have your model sitting on top of an object relational mapper. Same in Django, same in Ruby on Rails, active record there. Right? Your models are implemented in terms of the infrastructure. So you're very tightly coupling your model to infrastructure, which is going to change. So anyone think Ruby on Rails is going to be really widely used 20 years from now? Probably not. Something else will have come along and replaced it. But Ruby might be used 20 years from now. So if you only write your model in Ruby, without coupling to some specific technology, you can carry that model forward and maintain it as you go. So I would recommend in a Python context using plain old Python objects for your model. It's exactly the same advice I'd give in Java, just use plain old Java objects for implementing your model. Don't copy yourself any particular technology. Put the domain model in the center. Wrap everything else around it. Many of the classic DDD approaches, when you read the, you could buy Vaughan Vernon's book, Implementing Domain-Driven Design, and most of the book is in Java. The last part is in .NET for obscure reasons. Most of those approaches will translate pretty directly, actually, into any other object-oriented language. You can sit down and you can read the Java code and say, well, it's pretty obvious what I need to do to make this work in Ruby or Python. Right. Some of the other patterns in there are significantly lighter weight to implement in the dynamic languages. They're just so much easier. Right? Because you're not having to put all this boilerplate in to keep the type system happy, which really doesn't get you very far anyway. And of course, particularly in Python, we have this saying, we're all adults here. Right? So we don't have all this public, protected, private nonsense. Right? But instead of that, we have some conventions, some rules that we apply in particular projects. So for example, we might have a rule or a principle, a design principle, we adopt in a project that says, well, it's okay for all of the, it's okay for the code in the aggregate root entity to directly manipulate the attributes of any other entity within that aggregate. That's fine, that's a convention, that's a rule. You don't need a programming language construct to enforce that. Programming language would just get in the way if it did. Some of these attitudes, if you've only ever programmed in languages which are a bit more bondage and discipline about this kind of thing, they can be really quite shocking when you first encounter these kind of very liberal attitudes from dynamic language community. And some patterns just disappear, really. They just evaporate. They're just not there because they're not needed. So, for example, in the example we use, the signatures of messages just disappear. We don't use them. They have no value. So there's a few Pythonistas in the room. We're going to finish a little early, I think, but concrete advice for implementing domain-driven designs in Python. You probably can't read this at the back. For into your constructors, always pass the ID of the entity as an argument. So really a mistake to be creating IDs within the constructor, because when you rehydrate an object from a repository, obviously you want it to have the same ID it had when it was first created 5 years ago. If you're creating those things in the constructor, you can't do that. I found it's really useful to maintain a flag, which is, I call it discarded. The reason for that is it's almost impossible to delete objects these days, right? Unless you're using something like C++ where you can actually delete objects, right? You can lose references to objects, and you can hope that you've lost all of the references to the objects, and the objects are going to be garbage collected or become unreachable. But it's very difficult to know that that has actually happened, right? And so you can inadvertently end up referencing an object that should be dead, right? So it's a very simple solution, but I find that just maintaining a flag within the object saying, I am dead, do not use me, is a really good aid to writing programs that work well. And of course, maintaining a version in your objects as you go, so any change to the entity bumps the version number. So this is the entirety of an entity-based class, which has been used quite successfully for DDD projects in Python. You see it just has a constructor, thing for incrementing the version, get the ID, get the version, then ask, am I discarded? Do not use me. I find a lot of people struggle with how to organize code. Actually, no, they don't. If they're using the framework, they look in the framework documentation and organize their code that way. Right? You put your controllers here, you put your model here. Right? But I've just said, don't use a framework, just build a model. Right? Now, if you're going to do that, all the advice has gone away. I have to give you some advice instead. So I'm not going to go through the details of this now, but there are some simple patterns and approaches you can use for how to organize your code. And the entire domain model lives within. We have a Python package which is named after the bounded context. So that's something that would replace from the ubiquitous language. Then within that we have a domain model package where we actually have our entity and aggregate definitions. All the infrastructure is on the outside somewhere else. I find it's very useful in a language like Python to have your entities make an enormous song and dance about whether the fact they have been discarded. If you can't read Python, the repr function is what is one of the functions used to turn an object into a string. That's what you see in your debugger usually, right? That's how the debugger represents your object. It's very useful to just check the discarded flag. Have your debugger print out discarded user rather than user. Just a nice way of checking object liveness. All the queries and mutating methods check object liveness, all the mutators implement a version. And we generate IDs in the factory, and you'll notice that the factory, which is really a very simple thing in this case, just uses the ubiquitous language. We don't create customers, right? A customer walks through the door of your shop, the customer has not been created. That customer has been there for a very long time, right? You register the existence of that customer in your system, right? We do not create customers ever, right? Immutable types, I'm not going to talk about this. It can be a little awkward to make probably immutable types in dynamic languages. In Python, you can do a thing like overriding set attribute, which is the machinery through which all attribute setting goes, and you can basically make that not work. I'll talk more about that. The entire messaging infrastructure you need within your domain model, because your domain model is standalone, you shouldn't have any external dependencies for sending messages. This is the entirety of the message handling infrastructure you need. It's one page of code, including some quite verbose documentation as well. There's three functions: subscribe, unsubscribe, and publish. That's it. That's the entire thing. course, all of this stuff becomes easier to use if you have a language with lambdas and first-class functions and all those things that you don't have in Java. Which is why a lot of this code that you see in the Java DDD examples just shrinks down to almost nothing when you write it in a language like this. So to go back to the static typing comment, your IDE helps you write lots of code that you don't need to write. Yeah, domain events again. In my case, every domain event is an object, and they're just set up to be immutable. So I've just overridden set attribute here to say, sorry, don't do this. Okay. There weren't so many Pythonistas in the room, so I'm not going to go through this in detail. Something else that I found very useful is just to stick a timestamp onto every domain event. So either you provide a timestamp when you construct the event, or if you don't, it's going to stick a timestamp on there for you. Extremely helpful, especially if you're using an event sourcing architecture or event sourcing persistence layer on the outside to replay events. So this is the entire event. This is the only event you ever need, actually. Right? When I construct it, this keyword arguments thing just allows me to construct it with a bunch of attributes. And they just get stored in the event. I mentioned earlier in the talk that repositories are usually the only thing in the model that is abstract. This is an abstract Python repository. This is a repository for users. The reason it's not called user repository is because it's sitting in a module called user, so it'd be user.repository. So it's redundant to put user repository on there. It's abstract. In Python, you can see that here we have a single abstract method. What I found is quite a nice pattern for most of the repositories I've made is they have a bunch of convenient query methods on them, like give me all the users, or give me all the users with a particular name, or give me the user with an ID, with a particular ID. These three methods here. All of those methods are implemented in terms of one generic an abstract method called users where with some predicate function, which usually be a lambda function I pass in. Right, and you can implement all of your queries in terms of users where. Users with red hair, users with names beginning with R. It's just a different lambda each time. Right? What's nice about this is that when you implement a concrete repository, which has to be out somewhere in your infrastructure, you only have to implement a single method to do that. Because you've deferred the decision about how the repository works, you can actually implement the repository on multiple different technologies and have those in the system at the same time. It's really nice for migrating from one technology to another. You can just have two repositories, pull all the entities out of one repository, stick them into the other repository, and the technology underneath can be completely different. Right? It makes technology migrations much easier. Right? And for each new technology, if you're smart about it, you might only have to implement one method. And of course, users where underneath might be a SQL query, it could be anything you like, how you implement that. The other nice thing about this approach is that if you want to, you can override these as well. Some of these implementations up here are sufficient, but maybe not very efficient. Right? So you can override those in the concrete implementation of this, but a much more efficient implementation of users with name. You can override that in SQL. So externalize the infrastructure. So, just rounding off, about 8 minutes to go, so kind of on time I think, or 5 minutes to go. Domain-driven design is a technique, or library of techniques and patterns and approaches you can use, the purpose of which is to manage the essential complexity of your domain. Essential complexity is the complexity you cannot get away from because it exists in the real world. You either have to ignore it or you have to model it somehow. Right? So, by and large, essential complexity is non-negotiable. Languages like Python, I would argue, allow you to minimize the accidental complexity of your solution, which which is all the optional complexity that we stick into our systems. Right? Type systems are accidental complexity because types don't exist in the real world. For example, there's a lot of other nonsense in our software which is accidental complexity. We all know what it is because we probably experience it every day. Generally, when we run into problems maintaining and building our software, we're not running into problems in the domain, much more we're running into problems that we've created ourselves, or our predecessors have created for us, God bless them. So, I think there's a really good combination to be had here. I think there's an awful lot of dynamic language programs out there which would really benefit from having a DDD, or would have really benefited from having a DDD approach applied to them. It might be too late for many of those systems now, but I think the people wanting to use dynamic languages should consider using DDD. And likewise, I think languages like Python and Ruby can do quite a lot for reducing the accidental complexity in dynamic language solutions. Thank you very much for listening. I'm going to finish there.